everyone. So in this video, I will be covering questions from theory of equations. In total, 4 questions were asked. So let us try to solve these problems one by one. So the first problem is, let S be a set of all possible integral values of lambda in the interval minus 3 to 7, for which the roots of the quadratic equation lambda x square plus 13x plus 7 equals to 0 are all rational numbers. First, we are given that lambda lies in the interval minus 3 to 7, but he's talking about the question is talking about only integral values, that is lambda belongs to z. So the total values that lambda can take are minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6. Lambda cannot take the value minus 3 and it cannot take the value 7. So these are the 6, 7, 8, 9 values it can take. Now we have to find out for which all values this quadratic equation lambda x square plus 13x plus 7 equals to 0 has roots which are rational number. So if this is the equation, then the roots are given as what? Roots are minus b plus minus square root of b square. 13 square is 169 minus 4ac. 4 into 7 is 28, so minus 28 lambda by 2a, so 2 lambda. So for this these roots to be rational, this thing has to be a perfect square, right? If it is not a perfect square, so that is like root 7, root 2, root 3, root 5. These are all irrational numbers. Adding them to something and dividing them with another integer, it will keep them as irrational. So this has to be a perfect square for these roots to be rational. Now, all I have to do is see if 169 minus 28 lambda is a perfect square for the values given as minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6. So let us just try to solve that for all the values. Lambda is equals to minus 2 is the first one. So this will be 169 minus 28 into minus 2, which is 169 plus 56, which is 225, which is 15 square, so perfect square. This is a pass. Lambda is minus 1. 169 minus 28 into minus 1 is 169 plus 28, so 189 plus 8 is 197, is not a perfect square, so this is not going to be considered. This shall be considered very easily. You can see is 169 is 13 square. Okay, so this shall be considered in the set S. Lambda is equals to 1, so 169 minus 28 into 1 is 169 minus 28 is 141. Again, not a perfect square. Lambda is equals to 2. 169 minus 28 into 2 is 169 minus 56 is 113, not a perfect square. So this is a very easy problem. You just have to spend some time in it, right? So 169 minus 28 into 3, 169 minus 84, this is what, 85, not a perfect square. Gone. Lambda is equals to 4. 28 times 4 is 112. If your maths is really good, your calculations is good, you can just do it without writing orally, do it orally and save on time. Not a perfect square. I have a lot of time because I'm not writing the exam, so I can spend as much time as I want. 29 is not a perfect square. Last value of lambda, 6. 28 times 6 is 168, which is 1. 1 is equals to 1 square. So perfect square. So for the lambda equals to minus 2, 0 and 6. Minus 2, 0 and 6. The roots are rational. So this is the set S. So sum of all these elements is minus 2 plus 0 plus 6 is 4. Hence done. This problem is done. Next problem. If alpha is the maximum value of 1 minus 2x minus 5x square, alpha is equal to maximum value of 1 minus 2x minus 5x square. So let us first find out the value of alpha. There are two ways to do it, right? There are two ways to do it. First, you consider y is equals to 1 minus 2x minus 5x square. You do dy by dx equal to 0, which implies minus 2 minus 10x equals to 0, which implies x equals to minus 1 by 5. You put this value over here, so y is equals to, or the maximum value alpha is equals to 1 minus 2 into minus 1 by 5 minus 5 into minus 1 by 5 whole square. So 1 plus 2 by 5 minus 5 by 25, which is 1 by 5. So 6 by 5 is the value of alpha, right? There is another way to do it, which is perfecting the squares, right? So this is what maximum value of this is. Let us try to solve this. 1 minus 2x minus 5x square is equals to 1 minus 5 common x square plus 2 by 5x equals to 1 minus 5 into x plus 1 by 5 whole square minus 1 by 5 whole square. So minus and minus will be plus. So 5 by 25 is 1 by 5. 1 plus 1 by 5 is 6 by 5. So as you can see from it, 1 minus 2x minus 5x square is this. So maximum value of this thing will be 6 by 5. Why? Because this value will always be, this whole thing will always be negative. The maximum value this can take is 0 when x equals to minus 1 by 5. So alpha is equals to 6 by 5 from both the methods. We have seen both the methods. Now let us move ahead. The next part is beta is the minimum value of this. Again, you can do whatever you want. Take a differential. So 2x minus 2 is equals to 0. This means x equals to 1. Put this value over here. So beta is equals to 1 minus 2 plus r is equals to r minus 1. You can complete the squares as well. So this will be x minus 1 whole square plus r minus 1. Minimum value of this is 0. So minimum value of this whole thing is r minus 1. So alpha is equals to 6 by 5 as we have seen, and beta is equals to r minus 1. So now 5 alpha x square plus beta x plus 6. 5 alpha x square plus beta x plus 6 is greater than 0. We know that alpha is 6 by 5, so 5 alpha is 6. 6x square, beta is r minus 1, r minus 1x plus 6 is greater than 0 for what all values of x, of r. Very easy, right? This is very easy. You just have to solve the values of r so that this is always greater than 0. So again, you can, what you can do here is, since this is an equation of a parabola, this will always be greater than 0 if discriminant of this is less than 0. That is this case. If discriminant is equal to 0, then we will have one root over here. If discriminant is greater than 0, we will have two roots. And all these parabolas are opening upwards because the coefficient of x square, which is 6, is greater than 0. So if it has to be greater than 0 always for all the value of x, this cannot have any solution. When does a quadratic equation does not have any solution? When the discriminant is less than 0. What is the discriminant? Minus b plus minus square root of b square minus 4ac by 2a. Those are the roots, and discriminant is what? B square minus 4ac. So this is less than 0. What is b? R minus 1 whole square. What is a? 6. What is c? 6. This is less than 0. So instead of opening the squares, 4 is 2 square and 6 into 6 is 6 square. So 2 square, 6 square is 12 square. A square minus b square is what? A minus b into a plus b. So r minus 13 into r plus 11 is less than 0. We will do the wavy curve method. So minus 11, 13. So if r is lying between minus 11 and 13, this whole thing will be greater than 0. Minus 11 to 13. So this is the solution. Okay, next problem. For the equation x raised to the power 4 plus x cube minus 4x square plus x plus 1 is equals to 0, the ratio of sum of squares of all the roots to the product of the distinct roots is what? So nothing to do in this problem except solving for the roots. You have to solve for the roots. There is no other way to solve this problem. Let us put x equal to 1. 1 plus 1 is 2, minus 4 plus 1 plus 1. So 4 minus 4 is 0. So x equal to 1 is a root. Let us try to find out the remainder, the remainder of the expression when I divide this by x minus 1. So x cube will be there. Okay, let us do the whole long form division so that we do not make any mistakes, since we have so much time, because I'm not writing the exam right now. So x cube, x4 minus x cube, subtract, so sign change, this will be cancelled and this will be plus, so you will get this again 2x square. So what will you get? 2x cube minus 2x square, subtract, cancelled, minus 2x square plus x plus 1. Again you will get what? Minus 2x. So minus 2x square plus 2x. This is cancelled. You are left with minus x plus 1. When you do minus 1 here, you get minus x plus 1, cancelled. Since 0 is the remainder, we know that x minus 1 is a factor. We already knew x minus 1 was a factor. So you can write it as x minus 1 into x cube plus 2x square minus 2x minus 1. Now you have to factorize this big thing. Again, if x is 1, 1 plus 2 is 3, minus 2 is 1, minus 1 is 0. So x minus 1 is another factor. I will do the long form division again. I do not want to make any mistakes, hence I am doing it that way. X square, so x cube minus x square. So 3x square minus 2x minus 1. So plus 3x. 3x square minus 3x. So x minus 1. So plus 1. Again, x minus 1 is a factor and this is what is left with. So we have x minus 1 whole square into x square plus 3x plus 1 is equals to 0. So the roots are what? X minus 1 whole square. So roots are 1, comma 1. And what are the roots of this thing? X square plus 3x plus 1 is equals to 0. This implies that x equals to minus b plus minus square root of b square. So 9 minus 4ac minus 4 by 2a. So 2 minus 3 plus minus square root of 5 by 2. So minus 3 plus root 5 by 2 and minus 3 minus root 5 by 2. In the problem we are asked what is the ratio of sum of squares of all the roots to the product of the distinct roots. Distinct roots are these two are same, so their product is not to be considered. Anyway, 1 times 1 is 1. So the ratio that we are being asked is equals to 1 square plus 1 square minus 3 plus root 5 by 2 whole square, is whole square, plus minus 3 minus root 5 by 2 whole square divided by the product of the roots, distinct roots. So minus 3 plus root 5 by 2 into minus 3 minus root 5 by 2. So what is it? 1 square is 1, 1 square is 1. So this will be 9 plus 5 minus 6 root 5, 2 square is 4. This will be what? 9 plus 5 plus 6 root 5 by 4. You can take the minus out. So 3 plus root 5 minus 1 square is 1. So you can just ignore the minus in this expression. Similarly over here, if you take the minus sign out, this will be 3 minus root 5. Take the minus sign out, this will be 3 plus root 5. So minus minus plus. So you will be left with what? 3 minus root 5 into 3 plus root 5 2 into 2 is what? 4. When you add, you take the LCM. This and this have opposite signs, so they will cancel with each other. So 1 plus 1 plus 9 and 5 is 14. 9 and 5 is 14. So a minus b into a plus b. So a square minus b square. 3 square is 9. Root 5 square is 5. So 9 minus 5 by 4. 14 by 4 is 7 by 2. 1 plus 1 is 2 plus 7 by 2 plus 7 by 2. 4 by 4. 4 by 4 is just 1. So 7 by 2 plus 7 by 2 is 7. 7 plus 2 is 9. 9 divided by 1. This is the correct answer. Last problem, question number 4. Okay, so in this problem, I think the person, the professor, whoever has designed this question has made some mistakes, and I will let you know why. Let us first look at the problem. If alpha 1, beta 1, gamma 1, delta 1 are the roots of the equation ax4 plus bx cube plus cx square plus dx plus e is equals to 0, and alpha 2, beta 2, gamma 2, delta 2 are the roots of the equation ex4 plus dx cube plus cx square plus bx plus a is equals to 0, such that 0 is less than alpha 1 is less than beta 1 is less than gamma 1 is less than delta 1, and 0 is less than alpha 2, beta 2, gamma 2, delta 2. Then a bunch of equations are also given. Alpha 1 minus delta 2 is equals to 2 is equals to beta 1 minus gamma 2, and gamma 1 minus beta 2 is equals to delta 1 minus alpha 2 is equals to 4. Then a plus b plus c plus d is what? So first of all, if in a problem in which you have to solve each problem in like in an exam in which each problem you have to solve in like 1 or 2 minutes, this is like is a big problem. It will take like 5 or 6 minutes. It should not be asked in such an exam anyway. And second, you should make sure that there are no mistakes. So why am I saying there's a mistake? Let us consider this problem. This is the given equation for which the roots are given to us as alpha 1, beta 1, gamma 1, delta 1. Okay, whatever. If alpha 1 is a root of this equation, so a into 1 by alpha 1 raised to the power 4 plus b into this, sorry, why am I doing this? A alpha 1 4 plus b alpha 1 cube plus c alpha 1 square plus d alpha 1 plus e is equals to 0. Now this is the another equation, ex4 plus dx cube plus cx square plus bx plus a is equals to 0. If I put 1 by alpha 1 in place of x, what will I get? This. If I multiply this with alpha 1 raised to the power 4, I will get this. So this equation and this equation are same. They are exactly same. Hence, whatever be the roots of this equation, the roots of this equation are reciprocal of them. So if the roots of this equation are alpha 1, beta 1, gamma 1 and delta 1, the roots of this equation will be 1 by alpha 1, 1 by beta 1, 1 by gamma 1 and 1 by delta 1. Right? So if the roots of the first equation are given to us as alpha 1, beta 1, gamma 1, delta 1 for this equation, so then for this equation the roots will be this. But in the given problem, the roots are given to us as alpha 2, beta 2, gamma 2 and delta 2. So now I need to know if alpha 2 is equals to 1 by alpha 1, or if it is equals to 1 by beta 1, or if it is equals to 1 by gamma 1, or if it is equals to 1 by delta 1. So we have to map these roots. Reciprocal of which root is which root, we don't know yet. But for us, these conditions are given that alpha 1 is the lowest value and delta 1 is the biggest one value. Okay. So alpha 1 is less than beta 1 is less than gamma 1 is less than delta 1, and also all the roots are given as positive. So if the alpha 1 is 2 and this is 3, and this is 4, and this is 5, what will be their reciprocals? 1 by 2, 1 by 3, 1 by 4, 1 by 5. 1 by 2 is 0 0.5, 0 0.33, 0 0.25, 0 0.20. So the order of their reciprocals will be this, right? So if alpha 1 is the lowest value, then 1 by alpha 1 will be the biggest value. And if delta 1 is the biggest value, then 1 by delta 1 is the lowest value, right? So this will be the order of these reciprocals. And it is also given to us that alpha 2 is less than beta 2 is less than gamma 2 is less than delta 2. And these roots are reciprocals of each other. So by comparison, I can say alpha 2 is 1 by delta 1, beta 2 is equals to 1 by gamma 1, gamma 2 is equals to 1 by beta 1, and delta 2 is equals to 1 by alpha 1. Now let us look at the equations. Alpha 1 minus delta 2 is equals to 2. Right? And beta 1 minus gamma 2 is equals to 2 as well. Beta 1 minus gamma 2. So from here we see that alpha 2 is equals to 1 upon delta 1 and delta 2 is equals to 1 by alpha 1. So I will put this value over here. So alpha 1 minus 1 by alpha 1 is equals to 2 and beta 1 minus gamma 2. Gamma 2 is what? 1 by beta 1. This is also equal to 2, right? So now we have to think, since all the roots are also positive, right? 0 is less than alpha 1 and 0 is less than alpha 2. All the 8 roots are positive. So what are the possible values for alpha 1 and beta 1? Alpha 1 square minus 2 alpha 1 minus 1 is equals to 0. And beta 1 square minus 2 beta 1 minus 1 is equals to 0, right? So alpha 1 is what? Minus b plus minus square root of b square. 4 minus 4ac, so plus 4 by 2a is 2. Similarly, beta 1 is also 2 plus minus 4 plus 4 by 2, which is equals to 2 plus minus square root of 8 is 2 root 2 by 2. This is also plus minus 2 root 2 by 2. So alpha 1 is 1 plus root 2 comma 1 minus root 2. Beta 1 is equals to 1 plus root 2 comma 1 minus root 2. Since 1 minus root 2 is 1 minus 1.4 is minus 0.4. All the roots are given positive, so this is not possible, this is not possible. So alpha 1 has to be equal to 1 plus root 2 and beta 1 also has to equal to 1 plus root 2. But it is also given that beta 1 is greater than alpha 1, so how can this relation be satisfied in this case? So the examiner has made quite a few mistakes in this question. So that is why I was saying that there's a problem in this question. People will not be able to solve it in the exam. But I can see what they have done. They might have considered some conditions and forgot about the rest of the conditions. Okay, so let us not waste our time on this question because obviously there's a mistake in the designing. So these were the 4 problems that were asked in this exam from theory of equations. We will cover another topic, maybe calculus next. Okay, thank you everyone for watching my video.